All right, so we are doing I'm calling it a fact sheet rather than a cheat sheet. Do you like that? A fact sheet. What is the vertex form of a quadratic? F of x or y equals a times the quantity x minus h squared plus k. Got it? Now, let's talk about the transformations. Transformations is the general name. Transformations, there's 4 of them. Translation, which is shifting it. There's dilations, making it bigger or smaller. There's reflections, and what's the last one? Rotations. So under transformations, first we're talking about translations, shifting it left, right, up, or down. So the h value in here is going to be your horizontal, get it, h for horizontal, your horizontal translation. What's that really mean? It means you're moving it left or right on the x-axis. So I have some examples here to help us. So we're going to find all these things on this example, and we're going to break that down for each of these. Okay, so my first example is g of x equals x minus 3. Well, the h value here is positive 3. We want to be really careful with that because it's always x minus. So x is positive 3. My vertex is going to be 3, 0, because the k value is 0. So if you want to show that, k is 0. The axis of symmetry is x equals 3. That comes from the h value. The max or min comes from the k value, and that would be y equals 0. Now, is it a max or min? Well, my graph opens upward, so it would be a minimum at y equals 0. So in vertex form, I have all this information without doing any algebra. Now, if you look at the next one, the h here is negative 4, because this is x minus a negative 4 squared. Minus that negative gives me a plus 4. So my vertex, if I shift it to the left 4, my vertex now has moved to negative 4. Keep that 0. So remember, your parent function is right here at 0, 0, and we are shifting this 4 to the left, and it doesn't get any wider or any skinnier, so I'll just sketch that. This one moved 3 to the right, so it would look like this. Now, these are just quick sketches. They're not accurate graphs. My axis of symmetry would cut right through here, and in this one, it would cut right through the 3. So the axis of symmetry is always the x value of the vertex, and the minimum on this, since it didn't move up or down, is also y equals 0 at a minimum. Okay, so the next one I want to talk about is k. What does k do? Well, k moves it up or down, so k is a vertical translation. Vertical translation, which means it's going to move it up or down. So I've pretty much broken down each idea. So when I look over here, notice there's no h. There's no value paired with x that's squared with it. Nothing add or subtracted x, but it's added on the end. Guys, this is y equals x squared. Whatever you were going to square, you're adding 2 to that y value, which means you're moving it up or down. So here k is 2. So my graph would start at 0, 0. I'm going to slide this over, and it would go up 2 units, and it would be an upward facing u, because the x squared is positive. My vertex would stay at 0 and then be 2. My axis of symmetry would be at 0. It's going to cut right through here. Max or min, well, it's going to be a minimum because it's opening upward, and it'd be a minimum at y equals 2. Remember, the max or min comes from the y value of the vertex. Okay, I think I want to jump back up here. In vertex form, the vertex is h comma k. I want to add that in there. In vertex form, the axis of symmetry is x equals h. In vertex form, the max or min, you have to determine that by a, is y equals k. So if I know my vertex, I know all this information. Okay, so let's jump back down. The k value here is -2. And if yours doesn't have that, can you fix it? I did have a couple things I need to fix. So that means my start was here at 0, 0. I shifted down 2. I have another upward facing parabola. So 0, -2. My axis symmetry is still at 0. And this time I have a minimum again, but it's at -2. This is the lowest point on the graph. And from that, I could also pull my domain and range. On both of these, all four, domain is all reals, right? Negative to positive infinity. The range on both of these would be 0 to infinity. And the range here would start at 2 to infinity, -2 to infinity. Just by looking at that. Okay, the next thing I want to hit is getting into the scale factors. So I have some examples here. Again, if your example looks a little different than mine, I did have to make a couple edits. So first, if the absolute value of a is greater than 1, okay, let me get you back up here. Here's a. A is always paired with x squared. So whenever you look at this, you are going to make your graph wider or skinnier. And so whenever I have this, I'm doubling it. A is greater. It doesn't matter whether it's a 2 or -2. So the +2 is going to keep my parabola facing upward. The -2 is going to make my parabola face downward. Okay. So that's another thing we want to talk about and remember. But I'm talking about the values. So if the absolute value is greater than 1, so whether it's 2 or -2, my graph is going to have a vertical stretch. Vertical stretch. A vertical stretch will make my graph look more narrower graph. You could also call it a horizontal compression, because if I squeeze it in from the sides, it is going to make it skinnier. So those are all the terms you can use and you could hear. Okay, so in my first problem, A is 2, and that's why I have an upward parabola. It's going to be more narrow. Now, did this shift anywhere? Are there any H's or K's here? There's no addition or subtraction with X or on the end, so my vertex stays at 0, 0. I'm just going to have a skinnier graph. My axis of symmetry is X equals 0. My max and min, well, it's upward, so I'm going to have a minimum at Y equals 0. Now, I know this is pretty tiny, but I do have a graph that I want to go through because I think this really drives the idea home. We did some in Desmos, but I'm hoping this helps. So I have a chart here. I'm going to pick some x's like -2, -1, 0, 1, and 2. Now, this is x, and then x squared is like my parent function. -2 squared is +4. -1 squared is 1. 0, 1, and 2 squared is 4. So if I would graph my parent function, 0, 1, 1, 2, 4, I'm going to go ahead and graph this so we can compare it. And there we go. There's my parent function. Now, I'm going to come back in here with another color, and I'm going to actually do this function, which is 2x squared. So whatever x squared was, I'm going to multiply by 2. So now it's 8. So this point that was at -2, 4 is now at -2, 8, which is a bit off my graph. And -1 squared was 1. Now double it. The y value is twice as big. 0, 0 is going to stay. 1 times 2 and 4 times 2. So I have 2, 8 way up here, and I have 1, 2. What I want you to see is now my graph is being vertically stretched because the y value is twice as big as it was in the parent function. Okay? Now what's going to change here, if I have a -2, all my numbers are going to be pretty much the same, but they are going to flip to the negative side. They're going to reflect over the x-axis. If I go from a +8 to a -8, it's a reflection like I'm folding it here. So we're going to have those same first values, same parent function, so I don't have to graph that again. And then we are going to have a different function here. So whatever x was, you're now going to multiply it by -2. So I'm going to go to -2, -8. -1. So -1, -1. 0, negative, oh, not -1, -2. Sorry. -2 and -8. So let me fix that. That should be -1, -2, and 2, 8. And there is my downward facing parabola that is a little skinnier. So in this problem, A is -2. I still have a vertex at 0, 0. I still have an axis of symmetry at x equals 0, but I don't have a minimum. What do I have now in my orange graph? I have a maximum. It's still at 0, but it's now the highest point on the graph. Okay, so let's look at the next set of ideas here. Instead of having a nice integer number, or I don't even have to have an integer, it just has to be the absolute value greater than 1, I now have a fraction between 0 and 1. So if my a value, the absolute, is between 0 and 1, whether it's a positive or a negative, 1/2, 1/3, 1/4, I'm going to have a horizontal stretch. Whatever your y value was going to be, you took a smaller part of it. So this is going to be a horizontal stretch. It will make the graph look wider. And the other term for horizontal stretch would be a vertical compression. If I come down and I smash it down, it will look wider. Okay, so with that in mind, I've got my 1/2 x squared. So a is a half. The vertex, there's no shift. The axis symmetry, it's still at 0. This is opening upward because it's positive, so it's a minimum value at y equals 0. Now let's talk about our table. I'm going to put in those same numbers, -4, -2, right? -1, 0, 1, and 2. So 4, 1, 0, 1, 4. Got it? Whatever this was, and here's my parent function, 1, 1, 2, 4. Go this way. There's my parent function. I am now going to come in and take a half of that. So that 4 gets chopped down to 2. So when I put -2 in there, I only get out 2. When I put -1 in there, I only get out a half. So -1 1/2. I get 0, 0. I get a half. I get 2. And you can see that I have a wider graph. Do you see that wideness? Now, what's different about this guy? Well, he's going to go downward because there is a negative in front of the A. So I still have no shift. It's still going to be at 0, 0. X is going to be 0 for my axis symmetry, but this time I have a maximum. It's going to be the highest point, and that's at y equals 0. All right, let's throw in those same values. I guess I could have extended the table. 4, 1, 0, 1, and 4. It's already graphed. But I'm not just taking a half. I'm going to take the opposite. So this is now going to be a -2. So I start and I go to -2, -2. Take a half. That's me -1/2. So -1, -1/2. 0, a half, -1/2, and -2. So you can see that my graph is now downward and wider. All right, so we have 2 examples on the back of this paper, and I'm very limited on time, so I've already prepped them and done them. They're both in vertex form, so I have that over here. I pulled the A, the H, and the K. Remember, this is really a review. You've already learned this. And so the A equals -2 is going to give me reflection over the x-axis. So everything that I have is now going to be times -2. The absolute value of A is 2, so that's going to make it grow twice as fast for whatever x squared was. And so it's going to be a skinnier graph because it's going to have a vertical stretch. The -4, remember this was x minus a -4, is going to move it left 4 units, and k is -1, which is going to move it down 1 unit. Having this information, I can look at it and get my vertex of -4, 1. Did it already stop recording? Yeah. Well, it is what it is.